Hi, thank you for joining me. I'm glad to have you. If you have followed me from the beginning of this AC circuit to now, thank you for being there. We have discussed in our previous videos the RL circuit, we have discussed the RC circuit, we have discussed the AC circuit generally. Today I want us to look at R, L, and C circuit, these three components in an AC circuit put together, and then the power. Please, before we continue, if you have not subscribed to this channel, please hit the subscribe button, hit the like button, because that is what motivates me to continue to create more videos for you. Thank you. Now let us proceed. Now, assuming we have in a circuit where we have, this is our R, this is the L, we have this as our L, and we have this as our C. Now we have this as our AC source. Now we have this V, F, the VRMS, and the frequency. We have the R here, we have here as our L, and we have here as our C. Assuming a voltmeter is connected across the VR, it will record VR here. If another voltmeter is connected across the inductor, it will record VL. And if a voltmeter is connected across the capacitor, it will record the V sub C. Now remember, since this is a series circuit, here is our current. Current flows, the same current is flowing. Now remember, the first thing you will do is the vector diagram. The vector diagram. Vector diagram. Very important. Now, in a combination of these three components, you may be asked to get the vector diagram. Now, vector diagram look like this, and of course, there must be 90 degrees here, and then we have this one, 90 degrees. Yeah, VR points to the right. Now, to the left, we have the VL, voltage across the inductor. Now, if the other component, the voltage of the other component, which is C, is plotted, we now have a VC down here. Now, if you have this one, this is okay. In other words, it can also be, if this one can be compressed so that we can have just two dimensions. And if we have it, we cannot have this, or you can have it like this. Now, if we have it like this, we can have here as our VR 90 degrees here. We can have here, we write our VL, we can write our VL here. Remember, this is a Cartesian plane. This side is positive vertical axis, and this side is negative vertical axis. So here has negative sign. We can also bring it up. And if we bring it up, now that means we have minus VC. If we bring this one up. So, on this vertical axis, we can have VL minus VC. Please do not swap it. Okay, so if we have this now, we can now have, you complete, as usual, we are going to get the total voltage. Now, if we complete the shape, we'll draw a diagonal. Now, this diagonal, the resultant of this diagonal will give us the resultant of these 1, 2, 3 voltages here. V there. Remember, with this V is making an angle. The voltage is making an angle with this. This angle, we can call this angle phi. We'll look at it later. Alright, so the next thing now is to get the total of the voltages. 1, 2, 3. Total is just this. How do we get it? From Pythagoras, we can have from Pythagoras, we have V squared is equal to, now we take this first, which will give us VR squared two of them, VL minus VC all squared. Okay, or you can see how V is equal to the square root of VR squared plus VL minus VC all squared. Remember what we did in our previous videos. Please, for the previous videos, check the link in the description below. Now we have V is equal, we put the values of this, and if we put the values of VR, VL, and VC, we'll now have that, yes, square root of this will give us V, okay, we have IR all squared plus, open bracket here, IXL minus IXC all squared. You close this bracket. Now, if you bring i's common there, I want to jump a step there. If I jump a step there, when I have the V is equal to I square root of I squared R squared into I X all squared, all this is squared, minus I X, that is this one is squared also, C all squared. Now we have, from what you have is, I want to take I squared outside, and of course for me to take I squared outside, all I need to do is to take the square root of just the I. If I take the square root of just the I will come out. I will now have V is equal to I square root of R squared plus XL minus XC all squared. Now, this is what we have there. Remember, I can call this a particular factor. If I call this a particular factor, I will now have, please permit me to clean up here. Now, if I clean up here, we will have that, we'll say, let the whole of this, let square root of R squared plus XL minus XC all squared, we can say let it be Z. And if we call this D, Z, this equation will now reduce to V equals I Z, where the whole of this is Z. Of course, this Z, in our previous lesson, we called it the impedance. Now, the impedance, remember this is a reactance, this is a reactance, this is a reactance too. All of them put together will have a Z. And this reactance is nothing but, this impedance, please, is nothing but the overall reactance in an AC circuit, in a mixed circuit containing R, L, and C, the overall, the total reactance there. So we have this. Now from here we can now have I. Remember, I current flowing is the RMS, which will give us VRMS all over Z. So this is our equation. So we have that IRMS is equal to Z. Now we have this, which is the angle of inclination, the angle the VRMS is making with the resistive voltage, which is a VR. Now, for us to get that, we can now have, of course, this side is the opposite, while this side is the adjacent. Now, we can have a tan phi is equal to opposite all over the adjacent, which will give us the opposite side is this. And of course, what we have here, remember, we have here as VL minus VC. So that is what we have here. What we have here, the opposite all over the adjacent. So we now have VL minus VC all over VR, which will give us VL is equal to IXL. IXL, please permit me to clean here, minus VC. VC, if you transcribe it, you have IXC all over IR. I is common, I can take care of itself. And we will now have that tan phi is equal to XL minus XC all over R. So the reactance, depending on what you are given, we have this, we have this. So depending on the parameters given to you, you can work it out using the component voltage, which is a VL minus VC all over VR. You can also work it out if you are given the reactance of the inductor, reactance of the capacitor, and then the resistance of the circuit. So you can also get it. Tan alpha is equal to this. So that is this angle we have there, or the phase angle. We look at power in an AC circuit. And of course, we ask ourselves generally what power is. And we know that yes, power is the time rate at which energy is consumed. Now, in an AC circuit, the rate at which energy is consumed is power. Now, the power in an AC circuit is only absorbed in the resistance. So, since power is absorbed in the resistance, we now have that yes, power is equal to I squared R. Now, from this, if the voltage makes angle with any of either R or L or C, we now have that yes, power is equal to IV cos theta, where I is the current, P is the power, V is the voltage, the potential difference, V is the potential difference, PD, and theta is the angle of inclination there. Now we have what we call power factor. Now this power factor ranges between 0 and 1. Now a power factor of 0 means that that the device is either a reactance or an inductance or a capacitance. Now in this case we now have this, but assuming you now have that there's of course cos 0. You know what cos 0 is? You multiply it by this. Now because of that we now have that yes, P is I squared R, or we have P squared, P is equal to IV cos theta. So these are the two major equations concerning power in an AC circuit. Remember we said power is only absorbed in the resistor and not in the power is not absorbed in the inductor, neither is it absorbed in the capacitor. Now let us take some questions to add flesh to what we have just discussed. Please, should you have any question, feel free to drop it in the comment section anytime. I will respond to it, or you take me up directly with my personal WhatsApp. I will relate with you. We have this first question before us. The question says, the power dissipated in an AC circuit with root mean square current of 5 ampere root mean square. Voltage of the root mean square voltage of 10 volts and a phase angle of 60 degrees is dash. Now from this we have that yes, we are looking for the power. The RMS current of the voltage IRMS is 5 ampere. Now the RMS voltage there of VRMS is 10 volts. The phase angle there, the phase angle theta is given to be 60 degrees. Now we're looking for the power. Of course, there are just two formulas for power. The second one we go, which will give us that power is equal to IV cos theta, given this, and this. So we now have that power is equal to I, the root mean square, or either you have it like this, or you can say power is equal to I RMS V RMS cos theta. They mean the same thing. So which will now give us current in the circuit is 5 ampere times voltage, which is 10, times cos theta. Cos theta is 60, which will give us 5 times this is 50 times, of course, cos 60. Cos 60 is 0.5, which will now give us that the power is 50 times 0.5. Of course, half of this will give us 25 watts. So, and of course, is an OBJ equation. The correct answer there is option A. That is the correct answer option. Now, we'll still take the next one. Now, we have this question that says, when an AC is given by I equals 10 sine 120 pi t passing through a 12 ohm resistor, the power dissipated in the resistor is, the power dissipated must be among these options here. Now we have solution. The first thing is to write out the parameters given to you. If this type of question is given to you, please calm down, take the parameters one by one. If we have this type of problem, and of course we discussed the general AC equations, for the link to this, please see the link in the comment section. Now we have that the general equation for an alternating current is I equals I naught sine omega t, where if you liken this with this factor here is our amplitude current, and of course the amplitude current there is 10. We now say that amplitude current I naught is 10 ampere. Bring out the next one, R, which is the resistance, is 12 ohms. And then power is unknown. Of course, of the two equations, the first one will satisfy this, which will now give us power is I squared R. Now remember that this I is not just any R, is the root mean squared current. But from here, this is not the root mean square current. Find the root mean square current. Now to find the root mean square current, we say recall that I RMS, which is root mean square current, is equal to I naught all over root 2. Please, for details, see the link on how we can solve this. So if we substitute, we have that the amplitude current is 10. This is amplitude current, not the root mean square current. 10 all over square root of 2. And it will now give us square root of 2 is 1.414. If you take the ratio 10 divided by 1.414, it will give us 7.014. So it will give us 10 divided by 1.414 will give us 7.072 ampere. That is the root mean square current. At this point now, you can now substitute into this equation. If you substitute into that equation, we will now have that power is equal to current 7.072 all squared multiplied by R. R is 12. Now, if you square 7.072, if you square it, it will give us 50.1 multiplied by 12. Now, power will give us 50.1 times 12 will give us 600. To give us 600.7 watts. Now, of these options, we have this one, we have that one, and of course, 600. You take the nearest whole number, which is 600 there. Option B is the correct answer to this equation. We'll take another question. Okay, we have this problem. A series circuit consisting of 100 ohm resistor, a coil of 0.1 Henry inductance, and 20 microfarad capacitor. It's connected across 110 volts and 60 Hz power source. Draw the circuit diagram of the arrangement. II. Calculate the inductive reactance. III. Capacitive reactance. IV. Impedance of the circuit. V. Current in the circuit. And VI. Power loss in the circuit. Solution. The first thing to do is bring out all these parameters and then we draw. If we draw, this is the resistance, and then we have the inductance, and we have the capacitance. So which will give us this. Now V, F. V here is 110 volts, 60 Hz. Now the resistor is 100 ohm. The inductance is 0.1 Henry, and here is 20 microfarad. 20 microfarad. Remember, here is the current. This current, this is IRMS here. Now, we have answered the first question, circuit diagram. The VI, VR, VL, and VC are not required here. So, this is what you are needed to do. Now, the second question says, calculate this is the second question, which is the inductive reactance, XL. XL is, formula is 2 pi FL. Please, for clarity's sake, you can see the link in the description below. X is equal to this, which will now give us that XL is 2 times pi. Pi is 3.142 or 22/7. Multiplied by F. F is 60 Hz. Multiplied by L. L is 0.1. Now, at the end of the day, if we multiply all these things, we will have 2 times 3.142 times 60 times 0.1 will give us 37.7 ohms. Now, the second question says, the third question please, the capacitive reactance. Capacitive reactance, XC is 1 over 2 pi FC, which will give us 1 over 2, 2 times 3.142 times F. F is 60 multiplied by C. C is 20 microfarad. Micro, 10 raised to the power minus 6. So we have 20 times 10 raised to the power minus 6, which will give us 1 over, now 2 times 3.142 multiplied by 60 multiplied by 20 will give us 754.0.8 times 10 raised to the power minus 6. And of course, the whole of this will now give us XC is 1 over, we can have 0, convert this to ordinary form in order to help you press your calculator. But if you can handle it like this, feel free. So 0.007540. 1, 2, 3, 4, 5, 6. Okay. Now, inverse of this will give us that XC is 1 over 0.007540. It will give us that our XC is 132.6 ohms. 0.6 ohms is our reactance of the capacitor. Now IV is the impedance in the circuit. For the impedance, Z, so recall that impedance is R squared plus XL minus XC all squared, which will give us R is 100 squared plus XL. XL is 37.7 minus XC. XC is, this is our XC, 132.6. Remember, all squared. Which will now give us, please permit me to clean where we have solved so far. So, which will now give us, if we clean here up, we will now have that Z is equal to 100 squared will give us 10,000 plus, and of course, this is 37.7 minus 136.2.6 will give us minus 94.9 squared. Remember, by the time you take the square of this negative sign will go. So we now have that Z will give us 10,000 plus 94.9 all squared will give us 9,006.01. If you add this, it will give us, it will now give us square root of 19,006.01. Of course, the square root of this number 19,006.01 will give us 137.9 ohms. Therefore, the impedance in the circuit is 137.9 ohms. Now, having solved the impedance, the next one is the current in the circuit, which is V. Question V, current in the circuit, IRMS. Now recall that IRMS is equal to VRMS all over Z. Now VRMS from this is 110 all over Z. The impedance is 137.9, which will give us this over this will give us 110 divided by 137.9. We will have 0.797 ampere. 0.979 ampere. Now the last but not the least, which is the power loss. P is unknown. We know that power is I squared R, which will give us 0.797 squared multiplied by R. R is 100, which will give us, if you square 0.797, we are going to have 0.64 multiplied by 100. Therefore, power in the circuit will give us 64 watts. That is the value of the power in the circuit. Okay, please, if you find this lesson useful, please give it a like, share this video with your friends. Do not hold it to yourself. share it with your friends, because that is what motivates me to continue to create more videos. See you in my next lesson, where I'll be treating resonance. It's going to be hot. Thank you.